Hi, this is Oshiro Go, and welcome to my second ever YouTube video. Hopefully, I'll get a little bit better at this as I go along. Um, this is going to be about doing Perlin noise and just a real simple introduction to Perlin noise using Cocos2d-x. What I'm doing here, this is actually a sample that I'm shamelessly taking from the coding train, which has really awesome tutorials just on programming in general using P5 and JavaScript. And this is one such tutorial that I'm just taking and doing the same exact thing in Cocos2d-x, just to kind of get us introduced to how Perlin noise could work in Cocos2d-x. So I hope you will join me on this hopefully straightforward video. Let's see how it goes. Okay, so first of all, you can kind of see these nice effects here and these lines that are making these kind of waves around the screen. And before I get into the program aspect of it, let me just kind of show you the idea for how this works. So basically, you get your screen, right? You have a screen, like that. And what I'm going to do is I'm going to actually divide the screen up into grids, like this. Okay, something like this. Okay, so this is my screen of grids. And inside of each grid, I'm going to assign an angle. And this angle is going to be anywhere between 0 and 2 pi. And it'll just be some random angle. So like this, I don't know, I'll kind of make it like, this is how it could possibly turn out looking. I don't know. You kind of get the idea here. So kind of random angles. But actually, the trick is these aren't quite random, actually. These are semi-random. These are where the magic of Perlin noise is going to come in. I'm maybe not doing quite a good job of it, but I'm trying to make these angles so you can see if it was completely random, this angle could be over here, this angle could be over here, and it would be really random. But these are actually random, but they're related to each other. So you can see that these grids that are close to each other kind of have the same angle, and whereas these over here kind of have a different angle, but they're all kind of related based on how their neighbors' angles are. So that will be able to create kind of this field of angles. And what we're going to do then is we're going to create some random particles, or just basically dots on the screen. And these dots are going to have a position and then a velocity. And the velocity is going to be affected by this field, right? So if I put a random particle, let's say here on the screen, its velocity is going to be influenced by this angle here. So it'll get pushed up, and then it'll kind of be influenced here, like this and like this. So you can see, and then I'll have it kind of come back over here on this side of the screen. So this is kind of the basic idea of how this is going to work. And if you put a bunch of particles here, and they're all kind of tracing these paths, you should have that neat effect of that Perlin noise field that I just showed you. So that's going to be kind of the basic idea. Hopefully it'll go over all right. But in order to do this, I'm going to need a few things. First of all, I'm going to need this white screen, which is hopefully not too hard to make. And then I'm going to need this, I'm going to call it a force field, which is basically a matrix of all of these angles. And then I'm also going to need particles. And this force field will be using Perlin noise. So I have to make sure that I have a way to use Perlin noise. Yeah, and that should be all that I need to get going. So with that, let's go ahead and create our Cocos2d-x project. I'm just going to go back over here, close out of this. Okay, so I'm going to make it, let's do Cocos new, I'll call it Perlin noise. And then I'm going to make it in C++, and let's put it just on my desktop. Put it in a folder called PL. Oops, what's the problem here? Oh, sorry, I didn't specify the directory. Okay. All right, so I've got my project built here. Let's just go into it here. I'm going to open up the iOS Mac one because that's easy for me to use here with Xcode. Open up the project. Computer's being a little slow today. All right. So what I like to do the first time I create a Cocos project is there's a couple of house cleaning things. First of all, I'm going to be doing this on the desktop because that's faster than using the iPhone emulator. And then I'm going to be disabling the warnings for Cocos library because I don't care about these warnings and they're just annoying. So I'm going to inhibit. Oop, I don't see it coming up here. Oh, build settings. Inhibit all warnings, yes. Let's do the same here for the library. Okay, so that's one housekeeping thing. The other thing is I'm just going to go and clean up all this junk, this hello world junk that I don't need. So this menu close callback, I'm not going to be doing anything with any buttons or anything. Let's just go into here. I don't need any audio. I can get rid of that. Let's clear out this. And then in the init function, I don't need any of this crap. I'm going to keep this visible size because this will come in handy later, as you'll see. Okay, so that's the other thing. So now let's go ahead. We got everything set up. I'm going to go ahead and make this white screen. So that should be hopefully a easy first step. And to do this in Cocos2d-x, actually, it's a little bit funky. What I'm going to do is I'm going to be using, as you can see, my hello world inherits from layer. I'm actually going to inherit from a different class called layer color. And that will allow me to set the background color of my Cocos2d-x layer. So let's see, I need to do that. And then in here, where the layer gets initialized, I want to call, not init, I'm going to call layer color init with color. And I need to pass it in a color 4B, which I want it to be white. So I'm going to make this all 255. Okay, so that should be good. And hopefully now when I build it, I'll see a white screen. Okay, great. Nice boring white screen, yay. So first step is done. So let me go back to my paper here. So we got the white screen, I can check that off. Now I can either make the force field or the particles. Why don't I go ahead and make my particle? So this, again, as I was saying earlier, a particle, oops, you can't see that, can you? If I make a particle class, it's going to basically need, first of all, it's going to need, I'm going to use a draw node. So this is a Cocos2d-x object that actually lets you draw a dot on the screen. So that will be the one thing that I'll need. I'm also going to need its position. It's going to need a velocity. And then I'm going to apply an acceleration on the velocity. That will be this angle. And that will be what makes this velocity change gradually. So basically, that's going to be an acceleration. And these are all going to be vec2, which is basically just an x and a y. And that should be all I need for my particle. So let's go ahead and make one. I'll go back into my project here, and I don't know, maybe you guys have a better way of doing this, but what I like to do is I'll just take my hello world scene and just copy and paste it and rename it to particle. I've found, for me, this is the fastest way to create new classes. So I'll go ahead and create those and drag those into my project. I want to add it to my desktop. Okay. And then I kind of have to finagle this. So anywhere where it says hello world, I'll change that to be particle. This is totally not, I'm sure there's a better way to do this, but this is what works for me, so. Okay. And let's see. I should probably go and just do the same thing in here. I want to include the particle.h. Change this to particle. I don't need that. And actually, I don't need a create scene because this isn't a scene. This is actually going to be, that's a good question. So my hello world was a layer color. I want my particle to actually be a UI widget. Yes, that's what I want. I don't need this anymore. I want it to have an init function. Oh, there's an error there. I probably need to include where is it? I think it's UI Cocos2d-x. Okay, that Cocos2d-x. So okay. Also, since this particle is going to be moving across the screen, I'm probably going to want to have an update function that takes in a float of the delta time that is passed, and that will put in here too. So particle update. Okay. So far so good. And then like I had said, I want to have these things inside of my class. So I'm going to have, these are all, I'll make them private for now. A draw node, and I'm just going to call this particle node. And a vec2 for the position, the velocity, and the acceleration. All right. What's the problem here? Oh, you know what? I think, yeah, I need to include the Cocos namespace here. All right. Okay, so that should be good. Now, let's just make sure that this thing does something useful. I'll initialize my variables that I just made. Set this to 0, 0 for now. And then my particle node is going to be a new draw node, which I will use create to make this thing. And then I want to add that as a child. And then, oops, spelled it wrong. This particle node isn't actually doing anything yet. So let's, oh, I also want to schedule my update. So to make sure that my update gets called every frame. And then inside of my update, why don't I go ahead and clear the particle node, so that will kind of reset what it's drawing. And then I'm going to draw a dot on the screen. So there's a draw dot function here that takes a position, a radius, and a color. So the position, I already have that. That's my position. Radius, let's just make it 5 for now. And then my color, I'll just make it, needs a color 4F, so I'll do color 4F. And I'll make it a black dot, just passing 0, 0, 0, 1. And okay, so I think that's a good starting place for my particle. Now, to actually put this on the screen, I need to include it in my hello world scene. So I'm going to include my particle header file, and then in my init, let's just create a new particle, call it P, and then just create it like that because it's a UI widget. I can do that. And then I want to add that particle to my scene here, so I'll just pass in P. Bam, let's see, we should see a dot in the lower left corner of the screen. Yep, there it is. Okay, that's good. Now let's make it a little bit more useful. So now it's a dot, but it's not really doing anything. Let's make it move. So to do that, I'm going to add the velocity to my position. And then actually, the velocities needs to be affected by the acceleration because that's what my force field is. So I'm going to add the acceleration to my velocity, and then I'm going to just reset my acceleration. And you'll see later this should work when we're actually making the particle fly across the screen and applying that force field to it. And then right now my velocity, let's just set it to 1, 1. Let's just make sure that this thing actually moves. All right, it's moving across the screen, yay. So that's good. Oh, but it disappeared. So I need to make sure that it doesn't go off the screen, or actually, if it goes off the screen, I need to make it continue on the opposite side of the screen, if that makes sense. So I'm going to, let's just add a function here. I'm going to call this function check edges, like they did in the coding train video. I'll make a private method called check edges. And put that in here. And actually, this visible size variable, I kept it around for a reason. It's useful for stuff like this. So if my position x is greater than the width of the screen, then I want to set the position x to 0. Similarly, if it's less than 0, I want to set it to the width of the screen. And let's do the same for the height. So if position y greater than visible size dot height, position dot y equals 0. Otherwise, if it's less than 0, make it the height of the screen. Okay. Oop. What's the problem here? Whoops, I need to make this particle check edges. That should be okay now. And I need to call check edges here. Okay, let's see what happens now. So it's going, it's going, it's going, and boop, okay, good. So it looks like my edges method is working okay. Now, for my next trick, let me one particle is kind of boring, so let's put a bunch of particles on the screen. So I'm just doing one here. Let me create an array of particles and declare that as a private variable inside of my hello world scene. So to do that, and so I want this particle header. I want to put that in here now. And let's just do particle like this. Actually, it's an array of pointers, so I need the 2 stars there. And now, actually, I also need to say how many particles I need. So let's just make that a const int num particles. Let's just say 100 for now. We can change that later. So I want 100 particles on my screen, and let's just put them in some random place on the screen. So to do that here, I'll do a for I is less than the num particles, I plus plus, and I need to initialize my array as well. So particles equals new particle with num particles. I think that's the correct syntax there. And then here, particles at I is a new particle. And I want to add that as a child here. Okay, so now I'm adding 100 particles to the screen, but they're all going to probably be in the same position, right? Because they're all in the same position, they're moving at the same velocity, so it's not going to actually look like it has 100 particles. So let's randomize this a little bit. So actually, I'm going to include math.h because that's where the random function is. And actually, I'm going to seed using srand. I need to seed the randomizer here. So to do that, I'll just seed it based on the current clock time. To do that, I need to go like this, I think, time 0. So that should set my randomized seed. Then, inside of particle, I'm going to also include math.h, and let's make the position. So again, take a random place on the screen, and we need to go like this. I need to cast this as an int, I think, the visible side's width. Oh, and I need to do rand. Yeah, so I think that's how you do it in C++. And same thing for the height, just a random place between 0 and the height of the screen. So that should be good. And velocity, we can make that random too, I guess. Let's just make it between 0 and 2. I don't know. Same thing here. Okay, let's see what happens. We should have 100 random particles on the screen. All right, well, some of them, it's probably because my random velocity is 0. It's an integer between 0 and 2, which explains why some of them are stuck, but whatever. You get the idea. So we got all of our particles now, and for the next part now, we just need to create this force field and apply the force of this force field onto these particles. Okay, so how do I do that? I'm going to go ahead and make a force field matrix here, representing my graph. So I'll make a matrix of x and y's here, and in each one I'm going to put in this angle. So let's go ahead and make that. So I'm going to put that in my hello world scene C++ in here. So let's go ahead and make, I'll call it force field, and I'm going to make it array of vector 2. So like this, force field. And in order to know the width, or how many wide and how long it is, I need to have some other stuff too. So I'm going to add a grid size and grid width and grid height. And you'll see in a second why I'll need those. But let's go ahead and just make this matrix first of all. So I'll just go ahead and here. Right, so actually, let me set my grid size. Let's just make it, I don't know, 5. And then the grid width is going to be my width of my scene divided by the grid width, right? So let's go ahead and set that. That should be grid width equals visible size dot width divided by grid size. And same thing for the grid height. This is going to be the height of my screen divided by the grid size, right? So now I'm going to just create my matrix for, let's start with the x. Let's do x equals 0. We want that to go from 0 to the grid. Actually, what do we want this to be? We want it to go from, hang on, I just lost my train of thought here. Let's say, so the num of columns is equal to the grid width divided by the grid size, right? And same thing here, the number of rows should be the grid height divided by the grid size. And we want to floor this, I think. Yeah, okay. So now, start x at 0 and go to my number of columns. Okay. And same thing for the y. Okay. And then, so for my matrix, which I called force field, like this, and I'll pass this in the number of columns. And then for each column, I need to go like this. Force field at that column is an array of length number of rows. Okay. Then I just need to put in what this angle is. So force field at x, y. And I haven't figured out what that is yet. So for now, let's just put in vec2, 0, 0. Okay. Now that should be all right. Okay, great. So just make sure that it builds all right. Seems to be okay. Now what I need to do is, instead of this vector 0, 0, I need to pass in what I need to do is I need to get a Perlin value, right? So some random value for these cells, and then I need to convert that value into some angle, right? And that angle is going to be that vector 2. So first thing I need to do is get a random value using Perlin. So let's see. In order to do that, so I have this Perlin noise Did I make that yet? No. So that's my next step, actually. We need to somehow make the Perlin noise value. And to do that, I actually have here, if I open up my browser, there's some open source Perlin noise implementation. And inside of here, this has this Perlin noise header and C++ file. So let's go ahead and just, I'm going to get this off the internet. Okay, now if I extract this, I should have, yep, these here. So let's go ahead and drag and drop this Perlin noise implementation into my project, like so. Okay. So we've got our Perlin noise, and now I need to be able to use this library. So I'm going to, in my Hello World scene, I'm going to include Perlin noise. And then I'm going to give myself a Perlin noise object. Call it PN. Okay, so that's good. Now what I need to do is this Perlin noise object, in order to use it, I need to pass it a random seed. And that seed actually will determine what the values of the Perlin noise will be. So let's see, right here I'm initializing my randomizer. Right after this, why don't I just go ahead and create a seed? And it's an integer, and let's just make it some random value between, what, 0 and 1,000 or so. Okay, and now I think the way to do it is I go like this, and I pass in the seed. Okay, now I should be able to use this Perlin noise object to create a random Perlin noise value. And to do that, so back in my, where I'm passing in this vector to my force field, let's create a Perlin noise using noise. And you can see here it expects an x, a y, and a z value. So we have x and y they're ints, but this isn't actually quite right, but for now it's fine. And then our z value, for now, let's put it at some value, like I'm going to put 0.8. And actually these x and y values as well, they have to be a value between 0 and 1, because otherwise you don't know, when you're creating this Perlin noise, like I said, it has to somehow know like its neighbors. So it doesn't know how big this grid is. So if I just pass x and y as is, the values aren't going to be related to each other here. So what I'm going to do is I'm going to interpolate these x values divided by the width of the screen and the height of the screen, if that makes sense. That way I should have some similarity between these values. So to do that, I'm going to create, let's see. So again, it needs a double, so I'm going to do double and call this sample x. And that's just going to be, well, let's convert this x to a float and then divide it by actually this should be a float to the grid width. So that's our sample x. And then same thing for the y value. That should work, right? Not width, height. Now I just pass in sample x, sample y. Okay. And sorry, so let's call this Perlin value. Great. Now just to make sure this works, why don't I go ahead and just output the Perlin value here, see what comes out. Okay, so it's spitting out values, so that's good. Now I need to convert these values into an angle, right? So in order to do that, I want this angle to be between 0 and 2 pi. So what I need to do first of all is I need to convert this Perlin value, which is a value between 0 and 1. I need to make this a value between -1 and 1. Then that will make it easier for me to convert this into an angle. So all I need to do for that is just go times 2 minus 1, right? So that should fix that problem. Then I need to get, what I'm going to do is pass the cosine of this value to get the x part of the angle, and the sine of the value to get the y part of the angle. So to do that, let's just do, well, actually I could just do it directly in here. So if I do the cosine of the value, and actually I need to multiply this times 2 pi, right? I want that to be some random value between 0 and 2 pi, so I'm going to go like that. So that should give me my x, and the same thing for the y. Okay, now let's just make sure that this is working. So I'll go ahead and let's just output these values here. Let's see what happens. Looking here, so there's, yeah, seems to be okay, I think. It's kind of weird that they're all negative. I wonder why that is. Well, anyway, let's just kind of run with it. And oh, actually, they're not all negative. No, that's just weird. Maybe, oh, whatever. It seems to be doing something. So we have our force field values. So that's great. Now, the final thing that we need to do, so we have our force field and we have our particles. So I can check these off, right? We got our particle, we got our force field, we got our white screen. All we need to do now is we need to, this is kind of the magical part of the whole thing. So the force field values somehow need to apply to the particle, right? So what I'm going to do is I'm going to actually feed these force field values, feed this matrix that I just made into a method here. So I need to create a new method for the particle actually. I'm going to call that follow. So what this follow is going to do is it's going to take, it knows its own position already, right? And then based on this matrix, it's going to use its position to extract the current angle. And then it's going to apply this angle to its acceleration, and that will determine how the path of the velocity of this particle is going to change, right? So let's do that. So let's create this follow method. And then with that, we should be able to have everything we need to actually have this thing work. So how do I do that? So we have our force field. So inside of my particle, I'm going to create a public function and call that follow, and it's going to take my matrix of vector 2's here. And I also probably, well, let's just see how this goes. So follow in my particle C++, go in here, create a new follow. Okay, now let me think about this. So in order to actually use this force field to get, we need to convert our position to a place in the grid, right? So in order to do that, I actually need, I need to convert my, so int x position in field. That's kind of long. Let's just call it x position. And that will be my position.x divided by the width of the screen, right? So let's just use this thing again. All right. Oh, there's a warning here. Oh yeah, it's not being used. That's fine. And let's do the same thing for the y position. Okay. So the other problem is I don't know how many rows and columns I have in here. So I actually need to, I'm going to change this a bit. So I knew I had to change something. So I need to have my columns and rows passed into this function as well. So let's just do that. Where is this particle? Okay. And then, based on my x position and y position, I need to, let's say the x is going to be the floor of my columns times my x position, right? And I want that to be between 0 and the number of columns minus 1. I don't want it to be more than that, otherwise I'll get it'll try to access something outside of the array if it's at the edge. And let's do the same thing for my y position, except I will do rows, columns, rows. Okay, so we got our x and our y. So now the vec2 force should be my force field at position x, y, right? Then I just need to apply the force to my acceleration, right? And that should be all I need, right? What's the problem here? Oh, I'm not including, wait, no, I am. No matching function call for floor. Oh, I see. I made a kind of a mistake. What I meant to do was clamp. Well, I need to make this an integer, and I need to clamp it like that. And this I want to floor. Yeah, that looks right. Same thing here. There we go. I think that's right. Does that look right? So the x position is somewhere between, yep, nope, I got an extra parentheses in there. Okay, okay, now we're looking good. Now I just need to call this function from within my hello world scene. And I need to do this actually, right now I'm doing this in init, but I actually need to be doing this every frame because the position obviously is going to change. Well, let me just think about that. The particle, the force field right now is not changing. Let me see. Why don't I just pass the force field in when I initialize the particle, then inside of my particle's update function, if I just do follow here, so I'm going to change this around a little bit. So when I initialize my particle, I'm going to pass in this stuff. And then I'm going to keep these like this. Okay. Like so. Will this work? Oh, you know what? I can't. I'll create a new function here. No, it's not virtual. Let's go like that. So I'll call this init force field right after the init function is called, and that will set these variables that I will need. I'm talking to myself here. I hope this makes sense. So I will set my force field like so. Same thing for my columns and rows. Okay. What's the problem here? Oh, yeah. Okay. Bam. So now, oh man, let's see. So in my hello world scene, let's see, my particles. Okay. I'm going to initialize my particles after I initialize my force field. So let's move that down here. And then I'm going to call that method that I just made init force field and pass in my force field, my number of columns, and my number of rows. So that should be good. So then it's going to initialize the force field, and then in my particle, so this is initialized. In the update function, I'm going to call follow, and follow will look at those force field values and apply the acceleration based on where the particle is inside of my grid. So in theory, this should all work. Let's see what happens. Whoa. All right. Well, let's not panic here. So this, I think I know what the problem is here. For one thing, my particle, they covered this actually in the coding train tutorial as well. So we need to set a max speed to this velocity. We need to cap this, right? So I need to cap this. So I'm going to go ahead and set a max speed. And let's make that like 2 or so. And I'm going to make sure that my velocity doesn't go over this, right? So if my velocity x is greater than max speed, velocity x is max speed. I can do the same thing for the y. Okay, so that's one thing. Another thing I need to do is inside of my Perlin value, I think this is actually too extreme a value to be setting here. So I'm actually going to apply, I'm just going to multiply this by 0.15, just to kind of tone it down a little bit. And let's see, that should fix some of that problem. Okay, oh, it's still going fast. Oh, that's not good. Why is it going so fast? I might have to debug this a little bit, we'll see. All right, so I did a little bit of debugging here, and there's actually a couple problems that I found. So I'll just go ahead and fix those again. So one problem is actually this follow. I'm setting this acceleration back to 0 before I'm actually following it. So this acceleration will never actually do anything unless I put that before this. Another problem is that the velocity, I forgot to account for the fact that it can also have a negative velocity. So I need to also check in the case of the negative. So I'm going to see if it's less than the negative max speed, I need to set it to the negative max speed. So that was another problem that I had. Okay, so that's good. Another problem that I had that I totally missed here was that this needs to be a float because I'm taking it, otherwise it will just become 0. So I need to convert these to float. So I'm dividing a float by a float to get a float, and then I'm multiplying that by the number of columns and then flooring that. So this should be the proper way to actually get my position. So I think those are the only changes that I need to make here to get this thing working. So let's see what happens. Oops, no? What else am I missing here? That's weird. Oops, I forgot to make that a, there we go. Okay, oh, it's kind of, looks like it's kind of working. Let's try it again. Yeah, it's kind of working. All right, that's good. So the final step now, looks like these particles are applied, the force field is actually applying to these particles. All I need to do now is, instead of draw these dots, I need to actually draw those nifty lines on the screen. And so in order to do that, this particle node right now is drawing a dot. I'm not going to do that. Instead, I'm going to draw a line, and I'm going to remember my previous position and just draw a line between the previous position in the last frame and my position now. So that should give a nice curvy effect. So in order to do that, I need to go here, and in addition to my position, I need to remember my previous position, and then here, after I draw it, I'm going to set my previous position to my current position. I also need to make sure that this has a value at the beginning, and I'll just make that, actually I'll just make that the same as position here. Okay, so I have my previous position. Now I need to draw a line. From the origin to the destination. So the origin will be my previous position. Destination will be my position. And my color will be, while I'm at it, let's just give it a little bit of an alpha tint. I'm setting the alpha to 1, but let's just make it like 0.5 or something. Okay, and I don't want to clear it every frame now. I want to keep drawing it, otherwise it'll just show tiny little lines and it won't look any different. So I'm going to comment that out, and let's see what happens. Oh, okay. Oh, you know what this is? Probably, I need to check the edges. Yeah, the previous position, what happens is if the previous position's on one side of the screen and my position is on an, it switches over, then it draws those big lines. So how am I going to do this? I need to check the edges. If I move this after I draw the line, maybe that should fix that problem. Let's see. No, that's weird. Why is this happening? Okay, I see the problem. So the problem is I'm actually checking the edges. I need to check the edges before I set the previous position, but after I draw the line. I think that should do it. Okay, so see what happens. There we go. All right, so looks like it's working. That's a lot of particles, yeah. Well, you get the idea. So I hope you got something out of that. And again, you can play with these values, and maybe I'm drawing too many particles on the screen. I can try maybe setting it to be not quite so many. But yeah, I mean, you kind of get the idea. This is how these effects turn out. And again, I'm setting the random seed differently each time, so whenever I close it out and play it again, based on that random seed, it will create different Perlin values, so it'll create slightly different effects each time. But yeah, I hope this was a good introduction to Perlin noise and Cocos2d-x, and thank you for watching.